In the last video we saw how the determinant changes or doesn't change under various row operations, and we're going to use that to calculate some determinants. So first let's take the matrix A equals 1, 4, minus 4, minus 2, minus 2, minus 4, 3, minus 3, 3. So we could apply our formula of saying, okay, we pick one thing from every row so that no two are in the same column, we multiply them together and pick signs, but that's going to take a long time. So I am going to use these other tricks instead. So let's first of all use type 1 row operations to put this guy into echelon form. We're not going to change the determinants as we go along. So what do we do first? We want to get rid of this minus 2 and we want to get rid of this 3. So we're going to add 2 copies of row 1 to row 2, and we're going to subtract 3 copies of row 1 from row 3. So row 2 goes to row 2 plus twice row 1, row 3 goes to row 3 minus 3 row 1, and we're going to get what? Well, this will become 0. If I add 2 copies of row 1, that's adding 8 to minus 2, so I'm going to get minus 6. Sorry, plus 6. And if I add 2 copies of this, I'm going to get minus 8 of minus 4, so that's minus 12. In the bottom row, subtracting 3 copies of row 1, this is going to go away, this is going to become 0. If I subtract 3 times 4 from 3, I'm going to get minus 15. And if I subtract 3 copies of minus 4 from 3, I'm going to get plus 15. So that's those two operations. This is still not in echelon form. I have this 15 here to get rid of. So to get rid of that, what do I need to do? I need to do row 3 goes to row 3 plus 5 over 2 row 2. So the 5 over 2 is going to turn that 6 into a 15. So let's copy and paste this guy. So this minus 15 is going to become a 0. So let me just think, because I'm not so quick at this. Minus 12 times 5 over 2. So 12 over 2 is 6. 6 times 5 is 30. So this is going to be 15 minus 30. That's minus 15. Okay, and this is in echelon form. And these are type 1 row operations. They don't change the determinant. So rather than calculating the determinant of A directly, I can just calculate the determinant of this, which, remember, it's upper triangular matrix, all the non-zero entries are on the diagonal or above it, so I just get the product of the 3 diagonal entries. So it's 1 times 6 times minus 15, which is minus 90. Okay, let's do another example. Let's do a 4x4 example. So 2 minus 3 minus 1 4, 2 minus 3 2 4, 2 minus 1 minus 4 minus 3, 2, minus 3, 4, 2. Let's call this B. Okay, so again I can do row operations to turn this into something in echelon form. So first I've got to get rid of this mass of 2's on the left hand side. So I'm going to do row 2 goes to row 2 minus row 1, and the same for row 3 and 4. And you know, rather than watching me do this, you should just do it for yourselves and you know, fast forward and see if you got the right answer. Okay, so I know all that this is to cancel all these 2, so they're going to be zeros. So minus 3 minus 3 is going to be 0 as well. 2 minus 1 is going to be 3, and 4 minus 4 is going to be 0. That's row 2. Row 3, we've done the first entry. Second entry is going to be minus 1 minus 3, that's 2. Minus 4 minus 1, that's minus 3. And minus 3 minus 4 is minus 7. This last row, minus 3 minus 3, that's 0. 4 minus 1 is 5, and 2 minus 4 is minus 2. Okay. So what I'm going to do, just you know, to demonstrate what happens, I'm going to swap rows 2 and 3, because actually, you know, although this is not an echelon form, swapping rows 2 and 3 will make it a lot closer. So when I do that, let's see if I can. So there's row 2, there's row 3. Row 3 is going to go up there. Row 2 is going to come down here. You see, that looks a lot better. There's a lot more zeros down in this bottom left. But remember, when I did this, the determinant changed sign. So afterwards, when I compute the determinant of the echelon form matrix, I'll have to stick a minus sign in front of it to get the determinant of B. Finally, I want to get rid of this 5 here, so I'm going to subtract what? I'm going to subtract 5/3. Oops. Row 4 goes to row 4 minus 5/3 row 3. Going to need a new page. So this 5 is going to go away and become a 0. And the minus 2 is having 5/3 of 0 subtracted from it, so nothing changes. And this is now in echelon form. So the determinant of this matrix is 2 times 2 times 3 times minus 2. Just product of the diagonal entries, so that's minus 24. So remember, to get the determinant of B, I need to change the sign. So the determinant of B is 24. You can actually get away without doing this kind of thing, without switching rows. I could have, for example, added row 2 to row 3 to bring the 2 up to this here, and then used row 2 to cancel the 2 in row 3. That would have got me into echelon form eventually, but it would have taken a lot longer.